Okay, here are the solutions to the end of module on solving equations by trial and error. These questions are usually worth 3 or 4 marks. If you only write down a solution, you're going to get no marks. You must show your workings, and I think that a table is the easiest way to set it out so that it's clear, so the examiner can see exactly what you've done and give you credit for all your working. Okay, we have to solve this equation. We have to find the solution to 1 decimal place. Question tells us that the solution is in between 2 and 3, so we don't need to start guessing, substituting in whole numbers. We know that it's in between 2 and 3. The best place to start is 2.5 and then work from there. Because I'm short of space, I'm going to reduce the number of trial and error attempts that I put in here, but you write all of your attempts in. First one I'm going to try is I'm going to guess at x equals 2.8. Okay, use my calculator. 2.8 cubed, take away 3 lots of 2.8. Gives me 13.552. Write down all the decimals on your screen. We're looking for an answer of 15 for our value of x, so this one is too small. 2.8 is too small. Obviously the next sensible thing to try is 2.9. 2.9 cubed minus 3 lots of 2.9 is equal to 15.689, which is too big because we're looking for 15. So the actual solution lies somewhere in between 2.8 and 2.9. We don't need to go much further than that. We have to give our solution to 1 decimal place. So we just have to say whether the answer is closer to this one or this one. And the easiest way to do that is to try the middle value. 2.85 cubed, take away 3 lots of 2.85 is 14.599 and so on, which is too small. Now, in order to help you see which is the correct solution, a number line is useful. Where we know the solution lies in between 2.8 and 2.9. We know that this one is too small, this one is too big. We've tried the middle, which is 2.85, and we know that that is too small. Now what that means is the solution lies somewhere in this range here. Now we don't need to go any further because any number which is in this range here is going to round up to this value when we round to 1 decimal place. Everything to the left will round down, everything to the right of 2.85 rounds up. So whatever the solution actually is in there, to 1 decimal place it will be 2.9. Question number 2. Again, same thing. Table to help structure our workings and present them clearly. X, our guesses. Make sure that you get the equation exact. And then 110. The solution is between 4 and 5, so start trying 1 decimal place numbers between. I'm going to go for 4.6 first of all. 4.6 cubed plus 2 lots of 4.6 is 106.536, which is too small. So next I try 4.7. Which is 113.223, which is too big. So the solution lies in between these two. We need to work out which one it lies closer to. 4.65 cubed plus 2 lots of 4.65. 109.844, which is too small. So again, use a number line to help you get it clear. 4.6 was too small. 4.7 was too big. We tried the middle, which was too small. That means the exact solution to the equation is somewhere in there, and any value in there rounds to 4.7 when you round it to 1 decimal place. question number 3. Right, question number 3, part A, is a little bit more complicated. And I'll go through that in a moment, but just notice part B says use trial and improvement method to find the value of x. Give your answer correct to 1 decimal place. You must show all your working. And notice that in part A, the equation is written down there. Even if you can't do part A, this is a question where you could do part B following exactly the same method as in the previous 2 questions. And you could still score 4 out of the 6 available marks. Okay, so don't assume that just because you can't do part A, you're not going to be able to do part B. The equation's given. The method here is exactly the same as the previous 2 questions. Okay, the volume of the cube is found by multiplying the length, the width and the height together. X times x times x, which we can write as x cubed. The volume of the cuboid, again, is found by multiplying length by width times height. 5 times x times 2, we can write as 10x. Now we're told the volume of the cube is 100 centimeter cubed more than the volume of the cuboid. So if we take the volume of the cuboid and add 100 to it, that will be the same as the volume of the cube. The volume of the cube is 100 centimeters more than the volume of the cuboid. And if you subtract 10x from both sides, you're left with that, which is exactly what you're asked to show. And then on to part B. The process of solving the equation is exactly the same as the previous questions. Our values of x, our guesses, the equation x cubed minus 10x, and then we're looking for 100 this time. This time you need to find the whole numbers, which the solution lies between. They're not given. We try 5 cubed minus 10 times 5 is 75, which is too small. So next we try 6 cubed minus 10 lots of 6 is 156, which is too big. So the solution lies in between 5 and 6. Now we start trying decimal values. 5.4 cubed minus 10 lots of 5.4 is 103.464, which is too big. So next we try 5.3. Which is 95.877, which is too small. So the solution lies in between 5.3 and 5.4. So again, we try the midpoint. 5.35 cubed minus 10 lots of 5.35. 99.630 and so on, which is too small. Therefore, a final step, nice and clear, x equals 5.4 centimeters. And then just one thing before I finish, notice that every time I've done a calculation, I haven't wiped the calculator. So therefore, if I want to check any of my previous calculations, I can press the up arrow and scroll back through all the previous calculations that I performed.